Hello and welcome to class. In our last video, in the last class we held, we talked about the concept of the limits of a function, and we want to continue exploring that thought in this video. Okay, so let's get down to it. Now, let's look at this particular example. All right, a very simple one. Let's say that we want to take the limit of this function. Remember the notation. So you have limit. So we have limit x approaches let's say 2 of the function x plus 5. All right, so we have to take a limit of x as it approaches the value of 2 in this given function x plus 5. And what are we to do? We have to make a direct substitution. In other words, you want the value of x to be 2. So the x is coming down from negative integers minus 100 minus 10, and as it is approaching the value of 2, what will be the value of this function? All right, so how you would want to do that is you just go ahead and make a substitution. Therefore, since x is approaching the value of 2, so you're having 2 plus, so the 2 here is replacing the value of x that you have. All right, so we're having 2 plus, then we still have the 5, and 2 plus 5 is equal to 7. Therefore, the value of this function x plus 5 as x approaches 2, as the value of x nears 2 is 7. In other words, this value here, this function x plus 5 cannot have a value more than 7 as your x approaches 2. All right, let's try to look at, so if we should assume the value of x to be say 1, if the value of x is 1, when we put the value of our x to be 1 plus 5, that will give us 6, which is not more than the 7 that we already have here. If we even assume the value of x, that the value of x is minus 20, when we do minus 20 plus 5, that would give us minus 15, which is still not more than the 7 that we have when the maximum value of x is 2. All right, so that's basically what we are doing. So in this case, particular example, we make a direct substitution. Let's also look at another example and see. Let's say that we have to take a limit of x as it approaches, as x approaches 5 of the function, maybe say x minus 2 over x plus 1. All right, so we have to take a limit of this function x over 2 over x minus 2 over x plus 1 as the value of x approaches 5. Just like we also looked at in the last example, we go ahead and make a direct substitution. So our x being replaced by 5, so we're having 5 minus 2 in the numerator, and the denominator we are having x still as 5 plus 1, and all together that will give us 5 minus 2, that's 3, and 5 plus 1, that's 6. So 3 over 6, which ultimately, if you convert it to decimals, that will give us 0.5. So therefore, it means that the value of this function here, as x approaches the value of 5, is equal to 0.5. So this is basically how we take limits of any function. So you just make a substitution of the value. However, there are some cases. Let us look at this particular case now. All right, let's say we want to take the limit of this particular function now. Maybe say x. Okay, let me write. So we want to take a limit of the x as it approaches the value of x as it approaches 2, limit x as it approaches 2 in the given function x squared minus 4 all over x minus 2. Now this is a classic example. So we have to take the limit of x as it approaches 2 in this given function here, and just like we normally do, we'll go ahead and substitute the values of our x in the given function. So when we do that, we're having, when you put x to be 2, so you're having 2 squared. Alright, so you have 2 squared minus 4 all over x, that is 2 minus 2. When you simplify this, 2 squared is 4, so we're having 4 minus 4 all over 2 minus 2, that will give us 0. Alright, so 4 minus 4 will give us 0. 4 minus 4 will give us 0 over 0. Now you might think you have a solution here, 0 over 0, but when you go ahead and punch in your calculator 0 over 0, depending on the version of calculator you're using, you could get math error. In some other, it will give you invalid syntax. Alright, so we run into a problem when we divide anything by 0. In other words, in mathematics, you don't make a division, you can't divide anything by 0. When you divide something by 0, you get a math error, undefined value, syntax error, and all that. In other words, it means that we are having a problem here. We cannot take the limit of x as it approaches to in this given function. Alright, so this gives us a kind of a rule that whenever we take the limit of a function in the denominator, especially when you have a fraction, when you take the limit of a function in the denominator and you have a 0 as your denominator, it means that you have to work out the solution. It's not as simple as the case that we have here, where you make a substitution of x as 5 plus 1 gives you a 6. You don't need to do any further solving. But in this particular example, when we make the value of x to be 2, it gives us a 0. That means that we have to explore an alternative solution. Okay, let me also give you an example. Say if we should also say like want to take a limit. Let's look at this. So we want to take the limit of the function, maybe say x, as it approaches, let's say 3 now, or even 2. Let's use 3. X, the value of, take the limit of x as it approaches 2 in the function x squared minus 9 over x minus 3. Now looking at the denominator, that is this one. Now when you make the substitution of x to be 3, that will give you 3 minus 3, which will give you 0 in the denominator. And when you have a 0 in the denominator, it means that the solution is not simple. It's not as simple as it is. So you might have to do some manipulations, and that is what I want to take about look at in the next few examples, how we can be able to combat examples such as this, problem like this, and the one that we have here. Alright, when the denominator is giving you 0, what do you do? So let's come back to this particular problem that we have here, alright, and try to solve that. So we have to take the limit of x as it approaches to in this function, and having looked at the denominator, when we put the value of x to be 2, it gives us a 0. So what do we do? Now this is a cause for manipulation. Now when you take this particular one in brackets, right, when you take x squared minus 4 over x minus 2, when you take that apart, you can see that in your x minus 4, what you have there is what we know as difference of two squares. Remember that? So that passes, that's one of the, that's why it passes the conditions for difference of two squares. In other words, you can write that particular one to give us x, remember the difference of two squares, so we're having x plus 2 into bracket x minus 2, alright, all over x minus 2. Alright, so your x squared minus 4 is equivalent, is equal to this. X squared minus 4 is equal to this, because that is difference of two squares. Alright, and you still have your x minus 2 under still here. In other words, we have not done anything strange. Alright, we only try to rearrange the form of the problem that we have at hand. Alright, so x squared minus 4, when you implement difference of two squares, you have this, and your denominator x minus 2 remains as it is. In other words, it will be safe for us to say that So going ahead to continue, we have so it could be safe for us to say that limit, okay, let me like take that down a bit. So it means that the limit of x as it approaches to limit of x as it approaches to, please do not mind the writing, of x squared minus 4 all over x minus 2 is something as saying limit, is something as saying the limit of x as it approaches to of this one that we have here, because we have simplified the initial one to give us x plus 2 in brackets, then we also have x minus 2 bracket close all over x minus 2. all right, so we have this, so this function here, this function that we have here is equivalent to this function that we have here. all right, so x squared minus 4 over x minus 2 is something as saying x plus 2 in bracket, then x minus 2 in bracket all over x minus 2. all right, and we can go ahead and simplify. In other words, we can be able to cancel this, so we can cancel this, we can cancel this. X minus 2 cancels out x minus 2, and what we have left is that this expression here is equal to limit x approaches to of x plus 2. In other words, after we have cancelled out x minus 2, cancelled out x minus 2, what we are left with is this x plus 2. That's why we have it here. You can then go ahead taking limits, now taking the limits. all right, so you have simplified it, therefore going ahead to take limits, you might want to write that. So taking limits at this point, what you are having is a case of direct substitution. So you go ahead and put your x to be 2. In other words, we have 2 plus 2, and that will give us a 4. Therefore, the solution to this problem that we have initially, which is this one here, the solution to the problem, limit of x as it approaches 2 of x minus 4 over x minus 2 is equal to 4, as we have here. all right, so you might have to take your time and go over that again. Let's look at the other example that we have here. Okay, so remember that we ran into problems here when we substituted the value of x to be 3 in the denominator, that gave us a 0. So which means that we need to work out the solution, need to solve it out. So looking at this numerator here, you are seeing that that is also a case of difference of two squares. all right, because you can write that to be x squared minus 3 squared, and this means that we are having a difference of, because 3 squared is 9. So this particular expression tells us that what we are having is difference of two squares, as we have looked in the time past, the concept of difference of two squares. Therefore, we can go ahead and expand on that to be able to provide solution to the problem that we have at hand. Therefore, the limit of x as it approaches 3, in the function x squared minus 9 over x minus 3 is equal to limit x approaches 3 of, taking into account difference of two squares, we are having x plus 3 into bracket x minus 3 all over x minus 3. all right, so we can then go ahead now and cancel out. So this cancels this, and what you're left with is that this whole expression here, the limit of x squared minus 9 over x minus 3 as x approaches 3, is the same thing as the limit of x as it approaches 3 of the remaining expression that we have here, because we have cancelled out x minus 3. So what we are having there is simply x plus 3. Now I'm going ahead to take limits. So taking limits now. So taking the limits at this very level. So taking our limits here. So x will be made to be replaced by 3. So we are having 3 plus 3, and that will give us 6. And that is the solution to this problem. In other words, so we can go ahead on and solve so many examples in that, but the bottom line is that whenever you take a limit, all right, especially when you have a fraction and the denominator yields 0, it means that you are having an undefined expression, and you go ahead to factorize, try to look for a way to factorize the numerator so that you can be able to also you can also be able to solve that. All right, but when you go ahead and take a limit and no particular 0 is not being yielded in the denominator, it means that you don't have any issue. Now let's also look at this example. Say we want to take limit of x as it approaches 3, say for the function x squared plus 7, okay, plus 7x plus 3. So we want to go ahead and do this just to show you that it's not really for fractions that you take limits. You can take limits for linear as for quadratic equations, even polynomials as the case may be. Alright, for this particular case, what do? We go ahead and take limits. So taking limits as x, as x approaches 3, what do we have? We'll go ahead and substitute the values of x to be 2. So what we have to be 3. So we have, instead of writing 3 squared, we have 3 squared plus 7 into, our x is 3, so we have into 3 plus 3. So all this that we have here, that is what we have simulated here, but only that we have replaced the values of x with 3 that is given as a limit. This will give us 3 squared, that is 9, plus 7 into bracket 3, that's 7 times 3, that's 21, plus 3. Altogether, 7 plus 9 plus 21, that's 30 plus 3, that is 33. And this is your answer. So for this particular example, we do not need to factorize, because when we take a direct limit for the value of x, it gives us no 0 denominator, which will yield to undefined expression or syntax error or math error. All right, so this is basically what we are to do when we're taking limits of functions. All right, so go through the video, go through the examples, and make sure you are at home with what we have done so far. And after that, this you might as well try out these examples. Try out some of these examples to see whether you can be able to provide solutions to that. So try out this. So take limit, first one. This will be like an assignment. Limit x as it approaches 0 in the function 5x all over x squared plus 2x. All right, remember that you can factorize this denominator. You can factorize this denominator. That's a hint I'm giving you there. So try that out. You can factorize that to be x into x plus 2. All right, I'm just giving you a hint, but play around that and see what you come up with. All right, number 2, try out this one as well. Try to take limit x approaches 4 for the expression. Let's say x plus 4 over x squared minus 16. Alright, so try this out and see what that gives you. If there's any issue, let me know so that we'll take it from there. So I'll be seeing you in the next video. Remain safe and bye.